Welcome to the AI Coach by Anil Nathu. Today, we're embarking on a fascinating journey, a deep dive into decision-making theory. Think of it as understanding the secret sauce behind how we make choices, especially when faced with uncertainty. It's a skill that touches pretty much every corner of life, and, given your interest in smart, efficient learning, unpacking this will definitely be time well spent.
Absolutely. Decision-making theory isn't just some abstract academic stuff. It's really the foundation for everything, from your morning coffee choice to major business strategies and, well, even the logic behind artificial intelligence. Our goal today is to sort of chronologically explore how this field of thought has evolved, and we want to pull out the key insights and, the practical takeaways that you can actually use. We'll be drawing from quite a mix of areas, really. Psychology, economics, political science, even things like project management.
Okay, so let's rewind. Way back, right? Before spreadsheets and algorithms.
Yeah.
Where did people even start thinking formally about making decisions when they weren't sure what would happen?
Well, the very earliest formal ideas, they popped up around the 17th century. It was this concept of expected value. Blaise Pascal, the one with the famous wager, he really started this line of thinking. The basic idea is quite intuitive, actually. For any decision with uncertain outcomes, you list all the possibilities, figure out how good or bad each one is, and then estimate how likely each outcome is. Then you multiply the value of each outcome by its probability and just add those up. The option with the highest total expected value is, well, in theory, the most rational choice.
So it's like a super basic cost-benefit analysis, but with probabilities thrown in to spice things up.
Exactly, pretty much. But this early model, it had a well-known hiccup. The St. Petersburg paradox. This was back in the 18th century.
Yeah.
Imagine a game where you slip a coin, okay? You win $1 if it's heads on the first flip, $2 if it's heads on the second, $4 on the third, and so on, doubling each time. Mathematically, the expected value of playing this game is infinite.
Infinite. Wow.
Yeah, but nobody in their right mind would risk everything they own to play it.
Yeah,
right?
definitely not.
So this is where Daniel Bernoulli came in. His key contribution was expected utility. He realized, using this example of Dutch merchant deciding whether to insure his cargo, that the subjective value, the utility of money changes.
Yeah.
Depends on how much you already have. So losing $1,000 might be, a minor annoyance if you're a billionaire,
Right.
but a total catastrophe if you're just starting out.
Makes sense.
So he proposed using a utility function to reflect this diminishing marginal value. The more you have, the less impact each extra dollar has.
Okay. So it's not just about the dollar amount itself, but what that dollar amount means to the person making the decision. That makes a huge difference. So fast forward a couple of centuries, and it sounds like the field really started to solidify, get more formal.
Spot on. The early to mid-20th centuries saw the rise of formal decision theory, particularly with John von Neumann and Oscar Morgenstern's landmark work in the 1940s. Yeah. Their book, Game Theory and Expected Utility Theory, was a really big deal. They laid down what seemed like a very rigorous, rational framework for decision-making under uncertainty. Their expected utility theory was built on a set of axioms. Think of them as fundamental assumptions or rules.
Axioms. Okay. Sounds very official, like the bedrock of decision-making logic.
Precisely. And the idea was if you accepted these axioms, these basic assumptions, then it logically followed that maximizing your expected utility was the rational way to choose.
Got it.
And after World War II, this formal approach really took off, especially in economics. Thinkers like Milton Friedman started applying it to try and understand how markets work, how consumers make choices, that kind of stuff. Around the same time, we also saw the development of Bayesian decision theory. That brought in the idea of Bayesian probability, updating your beliefs as you get new information, integrating that into these decision-making models.
So we went from basic probability calculations to this whole formal system influencing economics, how we think about learning from new evidence. That's quite a leap. But was this purely rational actor model the final word? Because, I can certainly think of times my own decisions haven't felt all that rational looking back.
You're definitely not alone there. That purely rational model faced some significant challenges starting around the mid to late 20th century. Herbert Simon, in his 1957 book Models of Man, and actually in earlier writings going back to 55, introduced this crucial concept of bounded rationality. Initially, he used the term limited rationality, really emphasizing the sheer volume of information and, well, the brain power required for perfect rationality.
Like, it's just too much sometimes.
Exactly. Later, the term that stuck, bounded rationality, specifically highlighted the constraints on our rationality limits on time, information, and our cognitive capacity. This was a real game changer because it acknowledged that as humans, we don't have unlimited processing power or perfect information to always make the absolute best, most rational choice.
Bounded rationality. It's kind of a polite way of saying our brains have limits when it comes to making decisions. Makes me feel a little better about some past choices, actually.
It should. And the term itself is sort of gradually spread. Interestingly, the first full-length articles really digging into bounded rationality actually appeared in political science first in the late 50s and early 60s before it really took hold elsewhere. Simon also explored something called procedural rationality. Initially, that focused more on the logical steps of decision-making itself, but his later work kind of shifted its meaning, focusing more on how effective those procedures are given our cognitive limits.
So how well the process works for us, not just in theory.
Right. By his 1978 Richard T. Ailey lecture, he was really emphasizing how well the processes we use actually work, considering our human limitations, rather than just looking at the final outcome. But yeah, bounded rationality is what he's really best known for.
So recognizing these limitations opened the door to a more realistic understanding of how we actually decide things.
Absolutely.
Yeah.
This paved the way for what's called behavioral decision theory. It directly challenged the idea that we always make decisions based on purely rational, subjective, expected utility, or SEU. Researchers started to empirically test how well SEU actually predicted real-world choices. And from the mid-1960s onwards, there was just this flood of experimental work revealing these systematic ways, these consistent patterns in which our decisions deviate from what a purely rational model would predict.
And this is where the famous duo Kahneman and Tversky enter the scene, right? Like the rock stars who shook things up.
Precisely. Their prospect theory, which they outlined in a hugely influential 1979 paper, provided an alternative model for how we actually make decisions when there's risk involved. Not how we should rationally, but how we do. They highlighted several key psychological phenomena that SEU just couldn't really account for. For instance, the certainty effect. We tend to put a much higher value on outcomes that are guaranteed, even if the expected value of a slightly riskier option is technically higher.
Ah, yeah, that preference for a sure thing.
Exactly. And the isolation effect, where we often ignore aspects that are common to all our choices. This can lead us to make inconsistent preferences depending on how the options are framed or presented.
Like those optical illusions, but for decision-making, where framing the same info differently leads to totally different choices. I've definitely fallen victim to that.
Totally. And prospect theory also really emphasized that we experience gains and losses differently. This is the famous loss aversion. The pain we feel from a loss is often far more intense psychologically than the pleasure we get from an equivalent gain.
Oh yeah, losing $20 feels way worse than finding $20 feels good.
That's it exactly. Their model proposes two stages. First, an editing phase where we mentally organize and simplify the options available, and then an evaluation phase where we assess these edited prospects. They also introduced the concepts of an S-shaped and asymmetrical value function. Basically, this shows we're more sensitive to changes near our current situation, our reference point, and much more sensitive to losses than gains. And there's also a probability weighting function, which suggests we don't perceive probabilities objectively. We tend to overweight small probabilities and underweigh large ones.
So that explains why people might buy both lottery tickets, overweighting that tiny chance of a huge win, and insurance overweighting the small risk of a major loss at the same time. It's not strictly logical, but it kind of feels right to us.
Precisely. Prospect theory offered a much richer and frankly more accurate description of how we make choices in the real world with all our biases. For example, it explains why we tend to be risk-averse when it comes to potential gains, preferring a sure, smaller gain over a gamble with a larger potential payoff.
Right.
But we become risk-seeking when facing potential losses.
Mm.
We often prefer to gamble on avoiding the loss altogether rather than accepting a smaller, certain loss.
Interesting. Taking a chance to avoid the pain.
Exactly. And the idea of diminishing returns or diminishing marginal utility applies to both gains and losses in their model. So the psychological difference between gaining $100 and $200 feels bigger than the difference between gaining, say, $1,000 and $1,100. Same for losses.
Okay, that makes intuitive sense. Were there any criticisms of prospect theory? It sounds pretty comprehensive, but nothing's perfect, is it?
You're right, it wasn't without its critiques. One of the main ones is that it can be tricky sometimes to precisely define an individual's reference point, what they consider their neutral baseline. That can shift depending on the context or their expectations.
Yeah, that seems slippery.
There have also been discussions about how cognitively demanding the theory might be in certain complex situations. How much mental effort does it really take? And some research suggests that the influence of framing effects, while real, might actually lessen as people gain more experience with a particular type of decision. They might learn to see past the frame. It's the kind of ongoing refinement that systems like the AI Coach by Anil Nathu constantly engage with, reviewing these theories to improve the understanding of human decision-making.
Interesting point about experience. So, okay, we've talked about individual choices. Let's zoom out a bit to situations involving multiple players. How does decision theory tackle those strategic interactions?
Ah, right. That's where game theory comes into play. It's a whole framework specifically for analyzing situations where the outcome of your decisions depends not just on what you do, but also on what others involved decide to do. And while von Neumann and Morgenstern laid the groundwork for both expected utility theory and game theory really evolved into its own distinct and incredibly powerful field.
Like a mental chess match, yeah, where you're trying to anticipate your opponent's every move, and they're doing the same to you.
That's a perfect analogy. A core concept, especially in non-cooperative game theory, is the Nash equilibrium, introduced by John Nash back in 1951. A Nash equilibrium is basically a situation where no single player can improve their own outcome just by changing their own strategy. Given the strategies that all the other players have chosen, it represents a kind of stable point in the game.
So everyone's playing their best possible move considering what everyone else is doing, and nobody has an immediate reason to switch things up on their own.
Exactly. It's a point of mutual best response. And since Nash's initial work, there have been many refinements and extensions to the concept of equilibrium. Things like subgame perfect equilibria or trembling hand perfection, developed by Reinhard Selten, addressing more complex strategic scenarios.
Wow, okay. Sounds like it gets pretty deep.
It does. But what's really remarkable is how widely game theory has been applied, far beyond just economics. It's used in political science to understand things like why certain political situations remain stable or how coalitions form. In biology, it helps explain evolutionary strategies and animals think evolutionarily stable strategies. And even, as we mentioned, in project management, to analyze the relationships and decision-making between different parties like, say, government agencies and private contractors, or contractor versus contractor. All sorts of games play out there.
That's fascinating. And I guess AI fits in here too.
Absolutely. In fact, the AI Coach by Anil Nathu specifically utilizes principles of game theory. It helps in developing more sophisticated autonomous systems that need to make strategic decisions in really complex and uncertain environments, especially when interacting with other agents, human or otherwise.
AI using game theory to strategize that really is mind-blowing. So, okay, where does all this history leave us today? It sounds like we've moved from this idea of perfectly rational beings to a much more nuanced, maybe messier understanding of human decision-making in all sorts of contexts.
Precisely. That's the arc. Recent developments continue to refine our understanding. There's ongoing work in behavioral economics exploring the psychological and even the neurological underpinnings of our choices, like what's actually happening in the brain. There's also continued development of descriptive theories that try to generalize beyond standard expected utility to better capture the nuances of our preferences, especially in situations where the classic theory falls short, like with those Allais and Ellsberg paradoxes. It's a constantly evolving field, integrating insights from many different disciplines. And resources like the AI Coach by Anil Nathu are really valuable for staying updated on the latest advancements and what they might mean.
Okay, so we've journeyed through centuries of thought on decision-making. What are the key insights, the real light bulb moments that our listeners can take away and maybe apply to their own lives right now?
Great question. Let's distill some key takeaways. Firstly, and this comes straight from Simon, it's vital to recognize that our rationality is bounded. It has limits. We aren't perfect decision-making machines. Just being aware of our cognitive biases and limitations is actually a really powerful first step towards making more thoughtful, considered choices.
Right, so cutting ourselves some slack, acknowledging we're not always going to make the perfect rational decision. Got it. Humility helps.
Definitely. Secondly, remember that how a decision is framed can significantly influence the outcome. That's a big lesson from prospect theory. Be conscious of framing effects, both when others present choices to you and when you're evaluating your own options. Try to actively reframe the decision in different ways. What if I looked at it as a potential gain instead of avoiding a loss? It can reveal hidden aspects.
Looking at the same problem from different angles. Yeah, that's really good advice. Avoid getting locked into one view.
Insight number 3. Loss aversion is real and it's powerful. The fear of losing something often outweighs the desire to gain something of equal objective value. Understanding this bias can help you take more calculated risks when appropriate and avoid being overly conservative just because of the potential downside.
So don't let the fear of losing that follow, as you put it earlier, completely dictate your choices, especially if the potential upside is significant.
Exactly. And a related action item here is to consciously try and identify your reference points in different situations. What do you really consider your baseline, your status quo? Because this reference point heavily impacts how you perceive potential changes as either gains or losses.
Knowing your starting line helps you evaluate the journey more clearly. Makes total sense. What else?
Okay, lesson number 2 ties back to that probability weighting function. We don't process probabilities perfectly or rationally. We tend to give too much weight to small, unlikely events and not enough weight to large, highly likely ones.
Right, which explains the lottery ticket and insurance paradox we talked about. Those long-shot possibilities feel more real than they statistically are, and the almost certainties maybe feel a bit less urgent or impactful than they should. Good to keep in mind.
Precisely. And an action item stemming from acknowledging our biases is to actively consider multiple alternatives. Don't just get stuck on the first couple of options presented or the ones that immediately come to mind. Actively seek out and evaluate a broader range of choices. This can help counteract biases like the compromise effect, where we just pick the middle option, or anchoring on the first piece of information.
Widen the field before you narrow it down.
Okay. And finally, insight number 3, especially relevant in work and life. Strategic thinking is essential when others are involved. Your decisions and their outcomes are often intertwined with the choices of others. Thinking a few steps ahead, considering potential reactions and counter moves, like in game theory, can lead to much better long-term results than just focusing on your immediate preference.
Thinking like it's a chess game, or at least a strategic interaction, not just a solo puzzle to solve. Got it.
Exactly. You've got it.
Well, this has been an incredibly insightful journey through the evolution of how we think about making choices. Really, from those early mathematical models to understanding the quirks of our psychology and the complexities of strategic interactions.
Yes, it's definitely a story of moving from a purely logical, almost mechanical view of decision-making to a much richer, more complex understanding that incorporates the realities of being human and interacting with other humans.
So as we navigate an increasingly complex world, especially, with the growing influence of AI and decision support and even autonomous decisions, how can a deeper understanding of these theories empower us to make better choices? That's maybe the final food for thought I'll leave you with today.
That's a very important question to consider as we move forward.
Thank you for joining us today. Visit the AI Coach website for more AI insights by Anil Nathu.